Welcome. Thank you all. Thank you all for being here. Data science as a service. For the ones who heard me before, my Twitter handle, LinkedIn handle, feel free. Data science. As I see it, currently we're living in a firework era. That means all kinds of models are being shoot as rockets into the sky, and everybody's like, "Whoa, great, wow!" But they can't land anywhere. But why is that? Currently we have a platform as a service. We have software as a service. Why not data science as a service? Can anybody tell why we're not really having any data science, real actual data science models running in production or running in pipelines or something like that? I've never seen them. So I want to take you on a journey that I've been walking to with companies and looking at developers, looking at mentality of how we could achieve running those models into production. I also am going to give a demo of how it could be done by leveraging all the techniques we have nowadays for a platform, but also for services and applications. So, if you look at companies nowadays, 5 or 6 years back, you would see development, operation being separate, and science was more a BI thing, but there wasn't really actual science involved in IT. And just as we saw the opening keynote this morning by ABN, they also said, yeah, we're now transitioning to DevOps currently. But what about the science part? Many companies are still emerging to create a DevOps mentality, DevOps company, but you mainly see science, data scientists being a part of the team. So why not incorporate? Because if you look at what DevOps means, it literally means development and operations being responsible together for the entire life cycle of a product. And if you want to incorporate data science, in my perspective, the data scientist also needs to be responsible for their part of the product. So also the entire life cycle of training the models, serving the models, that sort of things. So if we look back, then and we're going to say to merely developers, yeah, we're going to help data scientists, but what do you want? Is that okay? Because the mentality for developers and operations guys, and also science guys, they have a different mindset. If you ever ask a developer, what do you want? They say, I want Java, I want to use Java, I want to use Kotlin, I want to use Scala, I want to do CI/CD, I want to do testing, all that kinds of things. But if you go to the operations side of your team, they all say, the first thing they say when they are working with Java developers is, no, please, no Java, no, memory, constraints, security, lag. That's one of the first things they say. But also, they want to use system automation. They want to use many different provisioning tools like Ansible, Terraform, Puppet, Chef maybe. And also, do some bash scripting, doing cloud init, and just gluing everything together. And then if you go back to the other side with the data scientist, if you ask them, what do you want? They merely say, no, I just want R, I want Python, and I want to use some notebooks. Okay, so how can we incorporate this? And the only thing I think that how it could be work is if you can all speak the same language. But then when you go to the developer and operations side, if you ask the operations, as we could see there, they say, please, no, no Java. Because I don't want to do Java. I've always done it this way, and this way is the exact way that I'm going to do it. But isn't that a bit rare? Because everything is evolving. The whole life cycle of products, development of products, but also deployment of products, it's a life cycle that is changing, that's going very rapidly. So I think for every people, just think outside of the box. Just go to operations side, go to the development side, go to the science side, go into the business and think outside of the box. And just, I'm not saying that you need to do everything the same. I'm just saying, just think as one and another. So, and because if you do that, together, you know things that the other person doesn't know. Basically, if you have 6 or 8 eyes of a team or 10 eyes, you can see more than you're looking with 2 eyes. Funny story about it is at a company where I did a project. We had a data scientist. He was very a part of the team, and he came to us. It's not working. We need more power. We need a bigger cluster. Everything, and basically, so we sat down with him and we asked him, "What do you want? What do you really? What you're trying to achieve?" And then he showed us his code, and we looked at it. And the first thing we saw was that he was trying to use 16 terabyte of data and loading it into memory of his local machine. Yeah, it wasn't possible. And then we said, this isn't working. Yeah, I know this isn't working. I'm getting this error. Yeah, what kind of error is it? And he said, yeah, it said Java out of memory. I don't know what it is. Okay. So we sat down with him and we explained it how he did it. So and we just altered his script that it could run and that he could chunk up his data. Just switching his mentality and his way of thinking. Another thing, when it was working, the next day he also came to us. Yeah, I know I have a problem. The cluster isn't running my data set. Okay, so the guy from operations came and he also looked at it. And he looked at the cluster and he said, yeah, okay, but did you address how much memory you can use? Yeah, I did it here. Yeah, it was 4 megabytes that he could use. So basically, tuning and working together solved many problems he had. So what I'm saying is, do not change the way you are, but just change the way you think. And that can only be done if you do it together. For example, if you look at the building in the picture, it's the Walt Disney Concert Hall. It's one of the most complex buildings. It's also created by an architect that uses destructivism as style. That means that he uses several building blocks, and it gives the impression that it can collapse every time in every moment. So basically, if you go outside of your comfort zone and try to understand one another, and you are not afraid to fail at something, you can achieve much and much more. So if we go back to the development part, the operation part, and the science part, if we ask what basically what operations want, they want a platform where they have all the freedom. They want provisioning using Puppet, Ansible, Terraform, or Chef. Orchestration, they want to use a Mesosphere, HashiCorp's Nomad, or Kubernetes. And if you now look at what developers want, they basically also want a platform on the cloud because it can scale and it can handle the workload they're creating. But if you look at the languages they mainly want to use, is Scala, Java, Kotlin, and TypeScript, because front-end developers are more than Java developers, according to Stack Overflow, sorry. And they want to run on serverless like AWS Lambda, Azure Functions, or Google Cloud Functions. They want to run it in on containers, on Kubernetes, and most of the front-end guys want to use Nginx. Now, the most strange part, if you ask a data scientist what he wants, is use libraries. You want to use TensorFlow, you want to use Keras, and all the libraries that are available, you want to do it in R, and you want to do it in Python. And if you ask him, where do you want to run it? Where do you want to run? How do you want to run it in production? He says, nah, I really don't care. Just you tell me. Okay, now that's a bit easy. So we're going to take it and just run it, and I'll give a demo of that later on. So if we summarize and we look at, I hope this works. Do you see it? No, you can't see it. Sorry. If you look at what operation development want, they tend having much of the same mindsets. And if you look at science, they have more overlap with developers. So if you look at it, okay, the scientists can best collaborate with development and use and extend the developers instead of operations. But they also need to use operations to get also things done, things deployed, things to production. So basically, it comes to this. The best teams understand, appreciate, and leverage one and another's talent. So make use of it. Just try to put yourself in the shoes of one another so you can work with each other. And for myself, I always try to put myself in the shoes of others. And I was looking for what is all the fuss about with all data science and development, and why is it so difficult to bring models to production. So for myself, I started, I want to do it in a product example type of way. So I tried it by creating for myself a fictional company called Plug and Pray. And I have a product owner who says, yeah, I have an application and I don't want any user without a profile picture, and I only want a user that has a profile picture and a happy face on it. Okay, so I started thinking, okay, yeah, nice requirements, how can I do it? So it's basically what I came up with. If I'm going to the whole life cycle, I'm creating I have an API gateway. I'm going to use serverless, in this case OpenVAS, as a serverless as a serverless provider. I will talk about that later on. I'm creating a Spring Boot application that leverages a database, and I'm going to train a model with Python and TensorFlow that does the recognition of a gender and also the type of emotion that it has on a picture. And I'm going to create a serverless handler for it that can serve it. So, I'm going to do a demo. Oh. Nope. Is that? Yay! It's working. So. Is it readable? No, it's not readable. So. Yay! It's readable. So, when I have here my face classification, and where I created a data set with also some trained models. And I first started with creating a simple web handler when it was trained with a simple Flask app where I have here a post handler that just reads the file, processes the file, and then returns. And if we look at this one, we have some detection models where here we are using the trained models on this here, and also for the genders and for the faces, I've trained a model with a dataset with images from IMDb, from the faces from people at IMDb with the labels. Loading the model, getting the emotion, decoding it, looking for the coordinates in the image, and then serving it back. So now I'm going to run it. And Python 3, source, web, faces. Okay, no module. That's the first thing I encountered, and when doing this, and then I also stumbled on that most data scientists just use their IDE on their laptop, and everything is included. So to make sure that everything is working on my local laptop, I need to create a virtual env. In Python, it's just an environment that's isolated with all the libraries you need. Export it and the base directory, adding it to my Python pod, and just then serve my Flask app. So I'm going to try it. So, okay, it started. So, and now giving it some up, I'm going to face classification, have some samples. Okay. And now I'm going to use the first one, a happy woman. Okay, takes some time. If I now look at the output on the other side, I'm here seeing warnings, warnings, warnings. My CPU doesn't use some instruction sets. Okay, and here is one of the first problems I had. I was looking into it, all the warning messages, and for some kind of way, it's normal for almost all Python libraries that are being used for data science purposes, is they all print errors to standard out. Why? I don't know, but that's a bit normal. Also, there are many print statements in all Python scripts that you have. So I put the image on my desktop and I had something, hey, it's a happy woman. Yeah, she looks happy. Another thing I also came across is Python also tends to use memory and compile, because a dynamically typed language, it compiles to a binary form, but it doesn't empty its cache. So if I'm now looking at my examples, and I, for instance, I now take a happy man, and I'm running it. Okay. It's invalid. Because, but why? Because it already has an element in its cache, and you need to clear it. You need to clear the cache before you can reuse the library. It's also a GitHub issue of TensorFlow somewhere on the backlog. So the only thing you can do is restart it. So if you look at one funny thing, why? I also tried an image of Trump. Can someone guess what the output will be of what his emotion is? Yeah, he recognizes it. No. It's a sad man. Yeah, because if you look at here, a general with an emotion, he's sad. Okay. So that was my model, and then I started thinking also the errors I had with basically with TensorFlow, that you need to rewrite your cache every now and then. I also looked at serverless frameworks, and mainly many of the frameworks that are out there, also AWS, Lambda, Azure Functions and all, they have the thing that they use hot loading. So for 10 minutes or 12 minutes, your handler is hot loaded and is being active for the moment. So using our TensorFlow backend and the Python cache was a problem. And there was only one framework called OpenVAS that literally is mere a controller for your functions. Was the only one that doesn't hot load. It uses a container, but it just initiates every request. It initiates the backend again. So that was the reason why I chose it. And if we look at it, at the function, You can give, in OpenFast, you can give a template and then use it for, and then just stick your code, your Python code in this particular case. You can just stick it in there, and you have almost no, you have to do almost no rewrites. So basically, you saw the Flask app, and the only thing I had to include, instead of using Flask, I can use a function. So here I created this little function, and I can build a container for it. And so then I have my serverless function, but also need an environment where it can run on. So the simplest way for me was to leverage the power of Kubernetes for it. So I literally deployed OpenFast to it. I'm very bad at typing and not that error prone with it, so I'll many times make scripts. So here I'm deploying my OpenFast backend to Kubernetes. And if I'm looking for the paths in my OpenFast namespace, one crash loop back off, that is because it's checking if it's already alive. But yeah, now it's inside Kubernetes. So I also need an API gateway for it, and therefore I used traffic. That is very and highly extensible API gateway. So if I'm API gateway, okay. So now I'm going to take my browser and go to yay! I'm seeing it running. Okay. So now, if I want to deploy it, because OpenFast has several CLI tools, and we have a definition for our stack here. I'm saying the language that I use in my template is a Python 3 with TensorFlow, a gender and emotion extractor, that's what I call it, the container, the Python path, the timeout that it has to know. Combine output. This is also a nice one, because combine output is, if you set it to false, all the errors we had in our script with using backend, TensorFlow, and all the warnings you see, they are getting scraped out of the output, and it only outputs to you the output that the script returns. And the content type is application/JSON. So fast CLI, I'm going to deploy. Okay, that's fast. Ready? And it says ready. Okay, I have one running, and I can use it. So now, this thing I now have running, so I'm going to use, I've created for the purpose, because the product owner said, yeah, he wanted a website and an application. So for this purpose, I created a simple application using JHipster. And that created a front-end and a back-end application for me. So I'm now going to deploy it. Oh. And if we look at the demo script, it's applying the demo, and here we have several files with it, and if I'm now service unavailable, but why is that? Now, it's plainly simple because the ingress controller is looking for a ready state, and it hadn't, and it didn't have one. So now we have an application running. You can change some languages to Dutch. Great. But still, we need to have our application, our model, being called. So in this demo, and also it uses a different domain. So in this, I created an extra backend for it called functions, with a service name, functions, and a port. And one of the nicest things is if I look at the service, describe service functions. What it does is it uses the external name, just it reroutes to another part of it, uses port and the endpoint. So now I can use my functions on the normal backend, but still I'm not there yet, because in my demo app I still have a little thing to do, and that is in the account part, because you only wanted me to register so I created a function service, and the function service is only going to check if it can, and only is going to check if the handler is alive and if you can deploy to it and create a call to it, handling a body upload, and then just here using mainly here, checking the emotion and then giving an error box and putting the submit button to yes. So, okay, let's try it. First, I'm going to use the, where are my samples? I'm going to copy the sample of the happy woman to my desktop. And now I'm going to be sure to reload it. If I'm now going to register, I don't see any button, but I can upload my profile picture. Then go to desktop and select the image. It's checking the image. And wait for it, wait for it. Yay! The emotion in the picture is a happy woman And now I have my register button. So if I'm going back and I'm selecting a happy man, it was the wrong image, it doesn't exist. Goes checking, and the demigods are not fun of me. So, the Trump image. Yeah, the saying he's sad and he's a man. So, for the demo, this worked. So, okay, and where is the rest of the screen? There. So, going back to summarize, what I actually did was I deployed a serverless framework to Kubernetes, deployed the application, and I containerized the model. And I altered the application to make use of specific other endpoints. So what have I learned from this acquisition? That is that libraries tend to change very rapidly. And mainly the Python libraries and R libraries, it's unbelievable how fast that world is changing. It's and also the libraries and the versions of the interpreters you use is also very crucial to your project, because if you alter it one version up, all the rest of the whole pipeline breaks. It's a bit the same as the Java 6 and transition to 7, that if you just updated one version, did one minor version bump, your whole application would break. Also, try to automate as much as possible from the beginning, because if you don't do it, you forget how that you trained your models, and how that you served some models, and also putting the Python environment in it, you also tend to forget it. So try to automate it from the beginning. And one other thing is, if you're working with data scientists, with engineers, with operations, with hardcore developers, make sure that everybody has the same interpretation of a solution. So, thank you all for my talk, and if someone has any questions, feel free to ask me. You can tweet it if you have a bit of an anxiety to ask me up in front, or just ask me at the bar later on. Thank you, and have a nice evening.